Have you noticed more aurora sightings lately, maybe even in places you wouldn't expect? We're talking Texas, Florida, even Mexico. The sun is gearing up for solar maximum, the peak of its 11-year activity cycle. And this time around, it's proving to be more intense than scientists initially predicted. So, what's causing all this solar activity? In this video, we'll break down solar storms, explain those mesmerizing auroras, discuss potential dangers, and look ahead to what we can expect in the future. The sun isn't just a giant ball of light. It's a dynamic, ever-changing sphere of hot gas with incredibly powerful magnetic fields. These magnetic fields are constantly shifting, twisting, and tangling themselves up. Think of it like a cosmic knot. Where these magnetic fields become concentrated, we see sunspots forming on the sun's surface. And these sunspots, they're the birthplaces of solar storms. Let's talk about the three main types of solar storms: solar flares, coronal mass ejections, and solar energetic particles. First up, solar flares. These are sudden, massive explosions on the sun's surface. They release intense bursts of light and radiation, like a cosmic flashbulb going off. This radiation travels at the speed of light, reaching Earth in about 8 minutes. Next, we have coronal mass ejections, or CMEs. Imagine huge bubbles of gas and magnetic field being blasted off the sun. We're talking billions of tons of material hurled into space. These CMEs are slower than flares, taking anywhere from 15 hours to several days to reach Earth. Finally, there are solar energetic particles. These particles are accelerated to near the speed of light by solar flares and CMEs. Because of their speed, they can reach Earth in just tens of minutes. That leaves us with very little warning time. The sun follows an 11-year activity cycle, going from a quiet period to a peak of activity and back again. Right now, we're heading towards solar maximum, expected to occur around 2025. But here's the thing, this solar cycle is proving to be more intense than predicted. That means we're seeing more sunspots, more flares, and more CMEs than anticipated. In recent months, we've witnessed some incredible solar storm activity. There have been several X-class flares, the most powerful category, including one that was nearly 9 times stronger than an X1 flare. As a result, auroras have been visible at unusually low latitudes. We're talking Georgia, Texas, and even Mexico. Social media has been flooded with stunning aurora photos from all over the world. So how do these solar storms create the beautiful auroras we see? When solar particles reach Earth, they interact with our planet's magnetic field. This magnetic field channels the particles toward the poles, both north and south. As these particles interact with gases in the upper atmosphere, they cause them to glow, creating the aurora. Stronger solar storms extend aurora visibility further away from the poles. Recently, we've had several major solar events occurring back-to-back. In fact, one of the strongest geomagnetic storms of the current solar cycle was recently recorded. Earth's magnetic field and atmosphere do a great job of protecting us from the harmful radiation released during solar storms. So the main effects we experience are on our technology. Solar storms can induce electrical currents in power lines. If these currents are strong enough, they can overwhelm transformers and cause blackouts. A notable example is the 1989 Quebec blackout, which was caused by a solar storm. More recently, we've seen voltage irregularities that have been managed without major problems. Increased radiation from solar storms can affect satellites orbiting Earth. This can cause glitches, damage solar panels, or even disable satellites altogether. To protect them, satellite operators often put their equipment into safe mode during strong solar storms. Solar storms can also disrupt the ionosphere, affecting GPS accuracy and radio communications. During strong storms, Airlines sometimes reroute flights away from polar regions to avoid communication disruptions. The good news is that our monitoring and prediction of solar storms have improved significantly. We've also upgraded our infrastructure to better handle most solar activity. Major catastrophic impacts from solar storms are rare. However, our increasing reliance on technology makes continued monitoring and preparedness crucial. NASA's Solar Dynamics Observatory, or SDO, is one of our most powerful tools. It captures incredibly detailed, high-resolution images of the sun. These images are taken in various wavelengths of light. This allows us to see details that would be completely invisible to the naked eye. SDO helps us understand the complex processes happening on the sun's surface. Another crucial spacecraft is the Solar and Heliospheric Observatory, or SOHO. SOHO uses special instruments called coronagraphs. These coronagraphs allow us to observe coronal mass ejections, or CMEs. CMEs are huge expulsions of plasma and magnetic field from the sun's corona. Coronagraphs work by blocking the bright solar disk. This allows us to see the fainter corona and any CMEs that are erupting. Many spacecraft are positioned at what's called the L1 point. This is a location about 1 million miles away from Earth, directly between the Earth and the Sun. Spacecraft at L1 provide early warnings of incoming solar storms. They can detect charged particles from CMEs anywhere from 15 to 60 minutes before they reach Earth. This gives us valuable time to prepare for potential impacts. All this data from these observatories is sent to places like NOAA's Space Weather Prediction Center. This center is located in Boulder, Colorado. Here, scientists monitor solar activity 24 hours a day, 7 days a week. These dedicated experts analyze the data and issue alerts when solar storms are predicted to impact Earth. These alerts are crucial for protecting our infrastructure and keeping the public informed. You can even get personalized alerts about solar activity right on your smartphone. There are many apps available that provide notifications about potential aurora sightings. These apps can help you plan your viewing opportunities. I'll include links to some recommended apps in the description below. Solar activity is expected to increase significantly through 2025 and into 2026. We're approaching what's known as the solar maximum. This is the period of greatest activity in the sun's approximately 11-year solar cycle. During solar maximum, we can expect to see more solar flares and CMEs. This also means there's a higher potential for more frequent and spectacular aurora displays. So, how can you make the most of this increased solar activity and see the aurora? First, follow space weather forecasts and use those handy apps we talked about. Next, find a dark location away from city lights. Light pollution can make it difficult to see the aurora. Make sure you have a clear view of the northern horizon if you're in the northern hemisphere. Sometimes auroras are visible to the naked eye, but even if they're faint, a camera can often capture them more clearly. Experiment with long exposure settings. While solar storms are beautiful, they can also have potential impacts on our technology. Preparing for a solar storm is similar to preparing for any power outage. Keep basic emergency supplies on hand. This includes flashlights, batteries, and non-perishable food. It's also a good idea to back up important data on your computers and devices. Consider having a battery-powered radio available. This can help you stay informed if other communication channels are disrupted. Ultimately, solar storms are more of an opportunity than a threat. They provide us with the chance to witness one of nature's most incredible spectacles, the Aurora Borealis. It's a truly awe-inspiring experience to see the sky filled with dancing lights. It's a reminder of the power and beauty of our universe. The sun's cycles have been ongoing for billions of years. Now, thanks to technology, we can predict and appreciate these events like never before. So, keep an eye on the night sky. There will be more opportunities to see auroras in the coming years. If you enjoyed this video, please like, subscribe, and share it with your friends. And if you've ever seen the aurora, share your experiences in the comments below. Thanks for watching.